Hello everybody. In this video we're going to be writing out the Lewis dot structure for this compound. We're going to start by writing down the different types of atoms we have. I see chlorine, I see carbon, and I see nitrogen. Next we are going to need to write out the electron configuration for these guys. So we got this configuration for chlorine, for carbon we get a configuration that looks like this, and for nitrogen we get 2s2, 2p3. We will get the valence electrons for these main group elements by summing the superscripts here. So this is 7 valence electrons. This is 2 plus 2, 4 valence electrons. And this is 2 plus 3, 5 valence electrons. Now we need to get our total. We've just got one of each, so we're just going to add them up. 7 electrons plus 4 electrons plus 5 electrons is going to give us a total of 16 electrons. Now we need our skeletal structure. We have to decide what our central atom is going to be. We want to pick the least electronegative atom to put in the center. That's going to be carbon. So we'll put carbon in the center. I'm going to draw it bound to nitrogen, and over here I'm going to draw it bound to chlorine. I had 16 electrons to work with. I just formed 2 bonds. Each of those 2 bonds required 2 electrons. I've got 12 electrons left to work with. I need to start by filling those out on the terminal atoms, the more electronegative atoms. Each of them can take 6 electrons before they've reached their octet, because they already have 2 from the bonding. So let's do that. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. I just placed 6 dots, or 12 dots, 6 and 6, so I've burned all my valence electrons, and I'm ready to look at the octets now. Chlorine, 1, 2, 3, 4, 5, 6, 7, 8, he's happy. Nitrogen, 1, 2, 3, 4, 5, 6, 7, 8, he's happy. Carbon, 1, 2, 3, 4. He is not happy. He's going to need to get 2 lone pairs shared with him at some point. Now, if you think about it, there's a few choices that we could have here. We could take both of the lone pairs from nitrogen. We could take both of the lone pairs from chlorine. Or we could take 1 lone pair from chlorine and 1 lone pair from nitrogen. Let's consider these 3 different choices for a second. First, we'll consider the case where we take 2 lone pairs from chlorine to form a triple bond there. And then we have nitrogen with the 3 lone pairs that it currently has. So that's one option. Another option is we form a double bond here and a double bond here. That would leave chlorine with 2 lone pairs, double bond carbon, double bond nitrogen, and he's going to have 2 lone pairs. So that is one of our options. The other options is we take both of these from nitrogen. That would give us chlorine, carbon, triple bond nitrogen with a single lone pair on it. Now, to make this decision, we are going to have to invoke formal charge. In order to calculate the formal charge, you calculate the formal charge for each and every atom, and in order to do it, we're going to start with their valence, number of valence electrons. So chlorine's going to start with 7, carbon's going to start with 4, nitrogen is going to start with 5. So for each of the chlorines, we have 7. For each of the carbons, we're going to do 4. And for each of the nitrogens, we're going to start with 5. Next, we're going to have to do a new count, but in this count, it's going to be different than our octet count. We're only going to count the bonds as 1, not 2. Each of the dots is still going to be 1. So our count for chlorine is 1, 2, 3, 4, 5, minus 5. For carbon, it's going to be 1, 2, 3, 4, minus 4. For nitrogen, it's going to be 1, 2, 3, 4, 5, 6, 7, minus 7. Here we have 1, 2, 3, 4, 5, 6, minus 6. This carbon is going to be 1, 2, 3, 4, minus 4. And this nitrogen is going to be 1, 2, 3, 4, 5, 6, minus 6. This chlorine here, 1, 2, 3, 4, 5, 6, 7, minus 7. This carbon, 1, 2, 3, 4, minus 4. Nitrogen, 1, 2, 3, 4, 5, minus 5. So this chlorine over here has a formal charge of 2 plus. This carbon has a formal charge of 0. This nitrogen has a formal charge of 2 minus. This chlorine here has a formal charge of 1 plus. 1 plus. This carbon has a formal charge of 0. This nitrogen has a formal charge of 1 minus. And over here, all of the formal charges are 0. We want the structure that's going to limit the formal charge as much as possible. So this is going to be our guy. And that is the way that that is the Lewis dot structure we would expect for this compound.